students and enthusiasts. Welcome back once again. Today I have come up with a new idea that is a very simple idea where we are using analog signals to control a robot. These analog signals are used from the IC, that is, we call it as an operational amplifier. So this gives us the idea that how important is the operational amplifier. So name of the project is Simple Light Following Robot Project using operational amplifier. I have used LM358 LDR. Two LDRs have been used and one motor driver IC we have used. We can use transistors also for H-bridge this thing, but I have used L293D H-bridge motor driver IC. This robot uses two light dependent resistor LDRs and operational amplifier to detect and follow the light source. It will follow the light source. A great way to demonstrate analog control, logic, sensors-based decision making. So when we study about a logical function, that is, we use operational amplifier mostly. So here, that is the project. All right. See in the picture, there is one LDR on this side, there is one LDR on that side, and the light is increased, the resistance drops, right? Changing the voltage output. That is, we have taken two output from this IC. So output will be constantly changing according to the light source. Okay. So please remember this operational amplifier already have two operational built-in amplifier in this, two operational amplifier in a single pack. Single comparison, that op-amp compares the voltage, right? And from the LDR, if one LDR detect more light, its op-amp out goes high. Same thing happens with the second one. Then the next point is left front LDR. There are two LDR here. This front and you can say this is back. So forward and reverse. That means this will come forward. This will come this side. And that will go push it to that side. So I have connected in such a way. Okay, the motor has been connected in such a way. I have not used the other part of the IC. If you want to make, we can use the other part of the IC for turning left and right. But since I just wanted to design a same forward and reverse, or the four wheels will start together, either forward direction or reverse direction. Okay. So let's see the first demo of the project. So now I will just show you how does it work. So we will see how does it work. What I will do is I will just put on the light on both the LDR and you can just check what is happening, what direction it is moving. So what I will do is I will just switch on the flashlight of my mobile phone. So I will just switch on there is a switch over here. There is a battery over here. I've kept it. It is going on the front direction. Okay, you can see it is coming on this side. Suppose same light I'm taking it to reverse this side. Now it is going, or the four wheels are going on the other side. Got my point? So this is forward and this is reverse. You can see the reverse, forward, and this is reverse. All right. Over. I will just show you the parts, So this is for front, that is LDR number 1, and this LDR number 2. There is a switch I have connected here. From switch, it is going to my batteries. The batteries can be kept inside also. That is on the first floor, or rather inside your mobile, your wheels. Okay, so you can keep it there also. So it works on that. So I've used two batteries, that is 7.5 volt. So I have used one regulator over here. That means my whole circuit, IC and whole circuit is working with 5 volts. That is output from this. So from here, the rail, that is positive rail, I have taken it to this place, positive rail, and the negative rail, I have taken it to the bottom side. Okay. So regulator 5 volt gives supply to whole of the circuit, but only pin number 16 of, pin number 8 of this IC, that is motor driver IC, which is here, which is given directly 7.5 volt because I am driving all the four wheels. So I need more voltage and more current for that. So directly I have connected to pin number 8 of this motor driver IC, right? Okay. And rest this side, that means two inputs are there. These two inputs only I have used it, two inputs, 1, 2, and 2 are motor out. On that motor out, I have given connection to all the four motors. That means the other side, there are two more connection, input connection, and one more motor can be connected on this, but I didn't connect. Okay, so this is my LM358 IC, right? Okay, so you can see here I have used two separate potentiometers. These are the preset, of course, but potentiometers, why one for one LED, one for one LDR and another one is for another LDR. So I have adjusted properly. Just the potentiometer should not burn. That's why I have used a low value resistance, which is going to ground and the supply. Okay, 10K is used from here, as I will be sharing all the circuit with this. And the output I have given through, because high to low and low to high, I have to convert. I have used 2P NPN transistor over here, and that will give the output from the collector is given to the IC input. Okay, so this is very simple circuit, and you all can do it to understand the operational amplifier. That is, without a microcontroller, how you can first for learning, especially for all the students of ITI diploma, and of course the beginners who want to learn, if they start with the circuits where you can drive the motors, so they can do it very easily. Please remember, microcontrollers, that is Arduino board or any other board, those things are very, very simple. But here you have to make more of a connection and you have to test or more of an adjustment. So this is a bit little learning. Okay, so I suggest my students to learn, and required two LDRs, you require one operational amplifier. You can use two operational amplifier also, but I have used, because this is a dual operational amplifier 358. So I have used both the operational amplifier. Only the thing I have used it two separate potentiometers, okay, for both the area. Okay, so 1358, that is operational amplifier, one edge bridge motor driver IC, that is, it is a 16-pin IC 293D. It is the L293D. Okay, then we have used two transistors, that is BC547 for reversing the states, that is high to low states. So I have used that. And DC motors, of course, 4 DC motors. That is, I have totally used a 4-wheel this thing, resistant potentiometer and battery. That is in between 6 to 12. That is, I have used approximately 7.5 volts, which I have kept it inside. Okay. Breadboard and jumper wires, as block diagram, to LDR goes 358. If it is connected to 358 and 358, you have L293D and two by BC547 transistor, and which will drive the motors. Very simple. Okay. Now this is a simple diagram. I have made it so that it will be easy for you all. So I have made a simple diagram of this particular subject. Please don't mind for this. It's a rough diagram, but I just wanted that you people should know about the diagram and all. So that's why I have. Right. Okay. So this will be, you can share the I will try to share this diagram with you. So real life application of this project. So solar panel orientation, that is to left when the sun goes from one side to another side. So panels should get the complete power, the complete sunlight. So that's why for that purpose we can use it. Second is smart lighting system. That is day and night light automatic system. That there also we can plant growth automation. There also we can use the lights, that intensity of light and starting of the motors and irrigating the plants and all. So these projects on based on LM, that is operational amplifier, we can do it. I hope you like this project, and certainly you will try to do it so that you can learn more about the circuits and the operational amplifier. Thank you very much for watching.